Hello students, how are you? Hope you all are well and doing great, enjoying your days, right? So let us come back to the lesson. We were doing chapter number 8 of NCERT book Science, it's motion, and this time we are going to do part 5. Last time, if you remember, we have learnt about equations of motion. This time we are going to apply those equations of motion. Students, it is not like that these equations of motion are only limited to your physics book or science book or notebook. It is also very useful. You can say all these three equations are useful in your daily life. Means if you know any three quantities out of the four quantities of a particular motion, you can find out the fourth one. Suppose you are traveling from one place to another place. If you know your initial velocity, if you know the acceleration, and if you know the time taken, you can find out final velocity. Or if you know final velocity, you know your initial velocity, you know the acceleration, you can calculate time. So let us see what are we going to study this time. This time we are going to cover up important symbols and their units, equations of motion, strategies for solving numericals, and sample problems based on equations of motion. Now, important symbols and their units. Last time, in fact, we have revised these symbols. This time, once again, I want you to recall all those important symbols. So, the first one is initial velocity. The first physical quantity we have taken here is initial velocity, and the symbol is U. SI unit is meter per second. Initial velocity can also be expressed in bigger units like kilometer per hour, but as per the requirement, we can convert into meter per second. Final velocity, it is given by the symbol small v, and SI unit is meter per second. Same here, the bigger unit can be kilometer per hour. Sometimes it can be even meter per minute also. But when you are expressing these things in SI unit, you need to use meter per second as a unit. Now acceleration, the symbol is a small a and the SI unit is meter per second square. Distance covered or displacement is given by small s and the SI unit is small m, that is meter. And time taken, the symbol is a small t and SI unit is second. So sometimes if you are given time in minutes, so you need to change it into seconds if you want your answer in SI system. Right. Now, let us move to the next slide, that is the equations of motion. We have learnt these equations of motion. There are three equations of motion, and each equation of motion has four different quantities. First equation of motion is V equals to U plus AT. If you know any three of these quantities, you can calculate the fourth one, as I have already told you. Now, second equation of motion is S equals to ut plus half at square. Again, you can see there are four quantities like displacement. You have initial velocity u, then time, then acceleration. So there are four different quantities. If you know any one of them, you can calculate the fourth one. So suppose if your friend is traveling and you know his initial velocity, you know the time taken by him, you know the acceleration, you can calculate how much distance has he traveled during his journey, right? Now the third equation of motion is v square minus u square equals to 2as. Again, you have four different quantities, V, U, A and S. Now, this time, as I promised you earlier that you will be studying or you will come to know how to solve the numericals. So we have some strategies for solving numericals. So let us note down what are the important points you need to keep in your mind when you are solving numericals. And as you are beginners, I suggest you all to give a pause to the video and note down these important points in your notebook. Like, first point is, note down all the given quantities at first. Means when you read the question given to you, you need to note down all the given quantities at first. Second one is, note down the name of quantity to find out. You need to find out what are you asked for. What are you supposed to find out as a solution or as the answer. Then, if an object starts from rest, take initial velocity u as 0. Please remember, this is very, very important. If in any question it is written the object starts from rest, it means its initial position is the origin, and there you need to take initial velocity as 0. Now, next one is, if an object stops by the end of the journey, the object stops after the journey is finished. It means now the final velocity is 0. It has come to rest, so final velocity will be taken as 0. Very, very important thing to be noted. Then, if an object moves with constant velocity, very, very important term once again. If you remember, we have drawn the graph for constant velocity. When constant velocity means when the velocity is not changing, speed is not changing, it means there is no acceleration. In that case, acceleration will be taken as 0. Okay. Now, next one is, if brakes are applied to the vehicle, take acceleration as negative. If brakes are applied, it means now the force is applied in opposite direction. So, you have to take acceleration as negative. If acceleration is 5 meter per second, then you will give a negative value to it. Means you will write acceleration is minus 5 meter per second square. Next one, if an object is dropped down from a certain height, means if an object is falling down towards the earth's surface, initial velocity is always taken at 0 at a starting point. Means when the object starts falling, the object was at rest. So, initial velocity will be taken as 0. Again, very important. Now, if an object is thrown vertically upwards, it is just the reverse motion, you can say, of the previous one. An object is thrown up, suppose a ball is thrown up. In that case, when the object or when it reaches the maximum height or the highest point, the final velocity becomes 0. This is again very important to note down. Please remember when you solve the numericals. We continue with few more important points. Check whether all quantities are given in the same system of units. It means that sometimes it happens that velocity is given in kilometer per hour, whereas time is given in seconds. It means you need to change kilometer per hour into meter per second. Means you need to bring all the quantities in the same kind of system of units. And usually we follow SI system. You all are aware of the system, right? And then just to make you recall, to convert kilometer per hour to meter per second, we need to multiply by 5 by 18. It is a simple fraction which you need to remember. Every time you need not to use the bigger numbers like 1 kilometer equals to 1000 meters and 1 hour equals to 3600 seconds. You need not to use those big numbers. You can simply use 5 by 18. This is very, very important fraction. To convert meter per second to kilometer per hour, multiply by 18 by 5. To convert minutes into seconds, multiply by 60. Now write all three equations of motion in rough column. Again, this is very important because you are beginners and you are learning all these things for the very first time. So, when you read the question, it might be possible that you are not able to understand that which equation has to be used. So, it is better you write all three equations of motion towards the right side of your page, that is in you can draw a rough column, a narrow rough column where you will write all three equations, and then you can select the appropriate equation of motion, that which one is suitable for the given question. Now let us take sample problem number 1, where you will read the question first, then you will note down the given quantities, then you will also find out that what has to be calculated or what is the expected answer. Like we can read the question at first. A car acquires a velocity of 72 km per hour in 10 seconds starting from rest. Find the acceleration. Okay, so a very good question, and this question is very simple. You need to first of all see the very important terms here, like a car acquires a velocity. When it is written acquires a velocity, it means it is about the final velocity. Okay, and time is given, you can see it is 10 seconds, and then you are given a very important key term or the keywords, you can see starting from rest, right? And find the acceleration. So question is quite clear. So as I told you that you need to like every time you need to note down the important equations of motion which you have already done. In rough column you will write that v equals to u plus at, s equals to ut plus half at square, v square minus u square equals to 2as. All these three equations you write in a rough column, and then it's time now to find out the given things. So as you have already encircled, that is starting from rest. So this is the clue. This is the very first clue we are getting here, that initial velocity u equals to 0. Okay. Then a car acquires a velocity, as I have already told you that this is about the final velocity. So final velocity is 72 km per hour. But you can see in the very next line it is written it acquires a velocity of 72 km per hour in 10 seconds. 10 seconds, this is you can say the time given here, but time is given in seconds, whereas final velocity it is given in kilometer per hour. It means you need to change kilometer per hour into meter per seconds. So how to change? Multiply 72 by 72 multiplied by 5 by 18, like you can see here. We have multiplied this 72 multiplied by 5 by 18, and then you can cancel 18 one time and 18 four times, right? So now 4 multiplied by 5 gives you 20 meter per second. This is the final velocity. Let us see next thing. How much time is given? It is 10 seconds. Then what is to find out? Acceleration. Which equation to be used now? You can see from this rough column that there are three equations, but as because this question is very simple, and at a glance you can easily make out that this is the first equation which we can use here. And in fact this you can also use the formula of acceleration, that is final velocity minus initial velocity upon time. Either you use the first equation of motion or use this formula, both are same. Okay, exactly similar, only it is the way we write them in a different manner. So acceleration equals to v minus u by t. Now let us solve, put up the values and solve it. Final velocity is 20 meter per second and initial velocity is 0, divided by 10. So 20 upon 10, it gives you 2. And let us see the units. It was meter per second here. Now this one is second. Finally, it becomes 2 meter per second square. This is the final answer. So you can say acceleration of the body or the car. Here the body is the car. Acceleration of the car is 2 meter per second square. So isn't it very simple? right? So if you take care of these things in your mind, you can solve the numericals very easily, right? Now we will be moving to next sample problem. Let us read the problem at first. The brakes applied to a car produce an acceleration of 6 meter per second square in the opposite direction to the motion. If the car takes 2 seconds to stop after the application of brakes, calculate the distance it travels during this time. Very simple, but again, as because you are beginner, you need to read the question twice. If you are not able to understand in first reading, you are suggested to read the same question twice and find out what important clues are given here, right? And as you were told that write all the three equations of motion in your rough column, so let us write them and then start noting down the given. Okay, so the very first one is acceleration. Okay, the brakes applied to a car produce an acceleration of 6 meter per second square. You can see it is given here. And students, sometimes when questions are given to you and you are not able to understand just by looking at the question, sometimes it happens that you are not able to understand that what is given here. Then these units also help you to find out that what is given. Like you can see here, the unit is meter per second square, and meter per second square is the unit for acceleration. So you can easily make out that this is the acceleration. If it is meter per second, then you can just take it as initial velocity or final velocity, right? And if it is given only in seconds, it means it is the time given. If it is given in meter, it means it is the distance or the displacement. Now let us see what else is given here. Please note, here it is written brakes applied and it moves in the opposite direction. So it is a very, very big clue. That is why you can see I have used a negative sign here. My acceleration is minus 6 meter per second square. Okay. Now car takes 2 seconds to stop. It means we are given time. Then what is to calculate? Calculate the distance it travels. Okay, so we have already drawn out what are the important things or the important clues given in the question. So let us solve it. Time taken is 2 seconds. Final velocity is 0. Very, very important, because here you can see that a very important word is mentioned here. Please, one more thing. It is mentioned here, it's stop. If the car takes 2 seconds stop, it means finally the car stops. And when finally the car stops, it means final velocity is 0. So this way you need to draw out, you need to find out all the important clues given in the question to find distance traveled. So let us see how can we solve this. You are given A, acceleration, you are given time, you are given velocity, you are given S. You have to find out S. Do we have all these four quantities in the same equation of motion? Let us find out. First equation, you have V, you have U, you have A, you have T, but S is missing here. So we cannot use it exactly to find out S. Then in second equation you have S, you have U, you have T, A and again T. So here you have U, but we are not given the value for U. Okay, no value for initial velocity is given. And in third one, you have final velocity, initial velocity, acceleration and distance covered, but here again you are not having the value of initial velocity. So it means you need to solve this question in two different steps. Okay, so let us proceed. What we are doing here, we are using v equals to u plus at. You know why? Yes, your guessing is right. If we use first equation of motion v equals to u plus at, we can find out u from here, and once you get the value of initial velocity u, now you can use either first or second equation to calculate the value of s, right? So this way we will proceed. See, let us put up the values. Final velocity equals to 0. Initial velocity is u, which is unknown. Acceleration is -6 and time is 2. So we will put up the values like this: u plus -6 multiplied by 2. Okay. So -6 into 2, it gives you 12, and when you transpose, you get initial velocity u equals to 12 meter per second. Students, please notice we can write meter per second either this way, or we can also write in this manner. Both mean same, only these are the two ways of notation, two different ways of writing. Okay, m s to the power -1. You need to read in the same manner, meter per second. So you have got the value of initial velocity, that is 12 meter per second. Now let us move to the remaining part of the questions. This time we are using second equation of motion, s equals to ut plus half at square. So here value of u is now ready with you. You have just found out the value of initial velocity. You know the time taken, you know acceleration. So just by putting up the values, you can calculate the distance covered. So s equals to, let us put up the values. U equals to 12 meter per second multiplied by time, so multiplied by 2 seconds, plus half multiplied by value of a, that is 6 meter per second square. Let me write square here. Okay, and value of t square, let us put up the value. Time is 2 seconds, and let us take the square of it also, right? So let us see. 12 multiplied by 2 gives you 24 meter, and here this half multiplied by -6 multiplied by 2 square. 2 square is 4. So basic 4 and this 2 are they get cancelled. So finally you are remaining with -6 multiplied by 2, and when you solve it you will find 12 meter. So 24 meter minus 12 meter, it gives you 12 meter. So this is your final answer. So have you noticed that in what manner have we calculated distance covered? We have used two different steps to find out the value of s. So sometimes you need to take help of two different equations to come to the final answer, right? And this way you can solve the numericals very easily. And thus you can say in this particular question, the car will move 12 meter before it stops after the application of brakes. So students, you all are suggested to practice such questions, and some questions are there in your NCERT book. Try to solve all those questions, and please follow all those steps which are told, and all those points which you are asked to remember and keep in your mind while solving. Please take care of these things, and I am very much sure if you follow all these points, if you remember all these points, then you will find the things very easy. So whenever you get time, please practice such questions in a notebook. Written practice is very important. Always remember this. And please like and share this video and subscribe my channel. Thank you.